In just 72 hours, the universe unleashed a chain of events that defied every rule of probability. 2 stars erupted bright enough for the naked eye, twin magnitude 6 quakes shattered Venezuela, and a solar storm slammed directly into 3I Atlas, the third interstellar visitor in history. The odds? Less than 1 in 1,000. Was it coincidence or something far more unsettling? When researchers first began logging the sequence now known as the 72-hour stack, they thought they were seeing coincidence. A nova here, a tremor there, maybe a flare on the sun. Natural, expected, explainable. But within hours, the story refused to stay ordinary. Instead of unfolding like isolated blips across the charts, the universe began dropping its pieces all at once. Telescopes in Chile caught a sudden surge of light, V1935 Centauri igniting in a runaway fusion burst. In Caracas, buildings swayed as a magnitude 6.2 earthquake struck near Mene Grande. In orbit, space weather models screamed that a coronal mass ejection was barreling toward the inner solar system. None of these alone would have raised more than a headline. Together, they formed something else entirely. To grasp how extraordinary this is, let's step back. Naked-eye novae are one of astronomy's rarest shows. You might get one in a year, sometimes none at all. This week, 2 of them, less than 48 hours apart. Quakes of magnitude 6 or more shake Venezuela once every 2 to 3 years. That week delivered 2, plus a strong aftershock within 6 hours. And CME impacts on comets? Almost unheard of. Yet here was 3I Atlas, only the 3rd interstellar comet ever identified, taking a direct hit. Each event on its own is remarkable. Combined, they form a statistical nightmare. Less than 1 in 1,000. Some say lower. The numbers drop so sharply they practically vanish into impossibility. And the physical details only deepen the unease. V1935. Centauri didn't just brighten. It blazed with gamma and X-ray shocks powerful enough to accelerate particles to near light speed. The Venezuelan quakes didn't just rattle windows. They triggered cascading stress transfers across the Oca-Ancon fault zone, reshaping crustal strain in real time. The CME wasn't just another solar storm. It arrived with perfect timing, intersecting the orbital path of 3I Atlas as if scripted. For seasoned observers, it was less like a series of random accidents and more like a pileup. A hand of cards dealt too perfectly. A reminder that probability doesn't always feel like chance. Statisticians even have a term, Poisson clustering. Sometimes chaos throws together a streak so uncanny it feels deliberate. But even Poisson clusters have limits. What made this so jarring was the overlap. Stellar eruptions, seismic ruptures, and a solar storm slamming into an interstellar visitor, all inside 72 hours. Each blow arriving as if cued by some unseen clock. So astronomers began to ask the same question, storming through forums and late-night labs. Was this just an improbable cascade, or evidence of a pattern no one had yet mapped? Because with the 72-hour stack, the deeper scientists looked, the less sense it made. If astronomers were rattled by the sudden nova and Venezuela's twin quakes, what came next threatened to dismantle one of the most comfortable assumptions in all of science, that rare cosmic and terrestrial events stay safely apart. Because under every probability model we know, this stack should not exist. Let's break it down. Naked-eye novae are so rare, they've been called once-in-a-generation fireworks. 1 per year is considered fortunate. Sometimes a decade passes without one bright enough to see unaided. Yet in late September, 2 erupted within 48 hours. V1935 Centauri and V7994 Sagittari both peaking near magnitude 6, visible to ordinary stargazers under clear skies. By the numbers, that's already staggering. But then came the earthquakes. Venezuela typically experiences magnitude 6 tremors once every few years. The crust along the Oca-Ancon fault absorbs and releases strain slowly, not in rapid-fire bursts. Yet within 6 hours, 2 ruptures struck nearly the same zone, unleashing a 6.2 and a 6.3 back-to-back, plus a powerful aftershock trailing close behind. The likelihood of such clustering isn't just low, it's almost absurd. And then came the sun. At solar maximum, eruptions are frequent, but the chance alignment of a coronal mass ejection with an interstellar visitor, that borders on fiction. Only 3 interstellar objects have ever been confirmed: Oumuamua, Borisov, and now 3I Atlas. To witness one of those tiny odds colliding with the already rare blast of a CME is like rolling dice across galaxies and watching them all land on 6. By traditional physics, cause and effect should keep these events separate. A nova in Centaurus should have nothing to do with Venezuelan geology. Venezuelan quakes should have nothing to do with plasma from the sun. A solar storm should never choose the path of an interstellar comet. Yet, in those 72 hours, they collided in sequence so tight it read like choreography. One researcher compared it to watching lightning strike the same tree 3 times while meteors fell overhead. Statistically possible? Yes. Believable? Barely. The contradictions piled up. Too many novae, yet too little time. Too many quakes, yet in the same location. Too much solar activity, yet intersecting with a comet no one expected. It became nothing less than a probability paradox. Some statisticians pointed to Poisson clustering, the tendency for random events to group together more often than intuition suggests. Sometimes chaos deals you a winning hand, but others argued the pattern here went beyond clustering. It looked stabilized. It looked deliberate. That's what made 3I Atlas the fulcrum of the entire debate. Because while novae and earthquakes can at least be explained, a coronal mass ejection slamming an interstellar object as rare as Atlas pushes coincidence toward impossibility. It wasn't just venting like an ordinary comet. It was being struck, tested, almost as if the universe, or something behind it, wanted to see what it was made of. Is that possible? Officially no, but then again, wasn't Oumuamua accelerating in ways no natural body should? If the first interstellar visitor broke the rules of motion, maybe the third could break the rules of probability. And so, the questions spiraled darker. Was this 72-hour cascade just a freak convergence of chaos, clustering on cosmic scales? Or was it something else, an engineered sequence, masked by the veil of chance? Whatever the truth, one thing was undeniable. The 72-hour stack wasn't just an anomaly, it was a direct challenge to how we define random in the universe. When the 72-hour storm of novae, quakes, and solar fire first came into focus, excitement was immediate. Astronomers knew each event on its own could dominate headlines for weeks, but together, the collision of data streams painted a picture no one was prepared to interpret. For a brief moment, it seemed like cosmic history in the making. The first nova alone would have been enough, bright enough to stir amateurs worldwide. Add in the Venezuelan quake and the CME's sudden acceleration, and the stage looks set for an unparalleled week in science. Researchers described it as watching nature write 3 different stories at once, each dramatic, each extraordinary. But just as quickly as that awe built, doubts crept in. The timelines didn't behave. Instead of fading cleanly into background noise, each signal left irregular echoes. Nova light curves wavered unpredictably. Seismographs picked up puzzling harmonics, as if the ground was still trembling beneath the data. Solar detectors registered sudden surges and dips, suggesting the CME wasn't dispersing smoothly through space. It was as if each event refused to resolve, caught between completion and continuation. And then came the revelations about Atlas itself. Unlike ordinary comets, 3I Atlas did not remain passive in the storm. Data showed its coma responding in strange, asymmetric ways. Portions brightened, others dimmed, almost as if the impact had fractured its internal structure. But here lay the paradox. Instead of collapsing, Atlas held steady. The CME seemed to rattle it, but not break it. Normally, when comets are struck by solar storms, they shed dust and unravel. Their fragile ices scatter. Yet Atlas appeared to resist. Its veil held together, absorbing the hit like armor. Instruments even hinted at fragmentation, but the fragments did not die. They continued to glow faintly, venting gases like miniature engines. This was no ordinary reaction, and so the question spread. Was this the chaotic resilience of an interstellar relic, or behavior that bordered on deliberate? Adding to the puzzle was the silence from institutions. Updates from solar weather agencies lagged behind amateur reports. Data about Atlas's asymmetric outbursts trickled out slowly, long after online observers had already flagged the anomalies. Rumors grew. Were agencies unsure of the interpretation? Or did the details sound too extraordinary to present without sparking panic? Either way, the story had shifted. What began as an awe-inspiring sequence of natural wonders transformed into something darker, a timeline fractured, a comet cloaked in resilience, a universe answering with riddles instead of clarity. And scientists were left staring into Atlas's haze, asking, if the rules bent once, how many more times can they break? For astronomers, the realization struck like a chill. 3I Atlas was never one of ours. It wasn't some forgotten comet returning from the Oort cloud or a stray fragment wandering from the Kuiper belt. Its path through the heavens betrayed its true identity. A body forged beneath another sun, a relic that drifted for eons before plunging into our skies. In orbital mechanics, a single number can rewrite the story. Atlas's velocity and inclination weren't just unusual, they were foreign. Its trajectory carved a retrograde slash across the solar system, steep enough to confirm what many suspected. It wasn't bound to the sun. This was a hyperbolic traveler, an orbit that enters once, then exits forever. A visitor, not a resident. That alone placed Atlas in extraordinary company. Humanity has recorded only 2 other interstellar guests. First came Oumuamua in 2017, an elongated enigma that spun through our skies, accelerating in ways natural comets shouldn't. Then Borisov in 2019, a dusty, icy comet that looked almost ordinary, a reassurance to skeptics. But Atlas looked like neither. It was massive, volatile, and now scarred by a direct solar strike, an object that carried secrets both chemical and cosmic. So the question loomed, where did it come from? Its structure and chemistry offered unsettling hints. Early observations suggested Atlas's activity wasn't driven primarily by water ice, but by a cocktail of frozen volatiles that resisted every familiar model. Its coma surged with asymmetry, venting strange gases in unpredictable waves. To hold such a composition, it must have formed in an environment utterly alien, perhaps a frozen desert orbiting a faint, distant star, where water was locked solid and exotic ices dominated. Imagine a realm colder than Pluto, a wasteland sculpted by a dim red sun where fragments of frozen worlds drift like shards of glass. The safe explanation is that Atlas is one such shard, a wandering relic ripped free from an alien system and cast into interstellar space. But the story darkens when you consider the sequence. First, an object that bent the laws of motion, then one that soothed our doubts. Now, a visitor that collides with probability itself, caught in the middle of the rarest solar storm of the decade. To some, it almost feels orchestrated, a prelude, a decoy, and then a spectacle too strange to ignore. Skeptics dismiss this as human pattern-seeking, yet others, quietly, admit it is hard not to feel a narrative threading through the chaos, as if these arrivals are breadcrumbs scattered across the stars. And then comes the greater fear: how many others have slipped by unseen? Detection is still primitive. We nearly missed Oumuamua until it was gone, a ghost that slipped past our telescopes. Borisov was spotted only because it vented dramatically. Atlas revealed itself thanks to its oversized veil and its unfortunate brush with a solar storm. But what of the darker bodies, the quiet ones that shed no light, reflect no glow, and pass invisibly through our skies? Have they already crossed our system in silence, hidden in the dark? That question unsettles astronomers more than they admit, because the truth is stark. Our solar system is no fortress. It is an open crossroad on a galactic highway. Interstellar debris roams freely. The comfort of imagining ourselves protected collapses once you realize we are simply another waypoint for drifters from other suns. And still, mysteries remain. Why did Atlas's veil hold so steady after the CME? Why did fragments glow with eerie persistence instead of dying? Does its resilience point to some exotic chemistry or something engineered, a structure built to mimic the natural only at first glance? And above all, why now? For centuries, we saw nothing. Then within just a handful of years, 3 visitors arrive. Is this merely the fruit of better telescopes, or is there truly a surge in objects entering our skies? And if so, why this timing, coincidence, or signal? If Atlas is a messenger, intentional or not, then its battered haze may be more than cometary drama. It might be a page in a story we are only beginning to decipher, a story written not in words but in wandering, impossible objects born beyond the stars. By now, the official narrative about 3i Atlas frames it as an extraordinary but still natural wanderer, an interstellar comet carved in another star system, volatile rich, and unlucky enough to cross paths with a coronal mass ejection. That's the safe conclusion. Neat, rational, comforting, but Atlas doesn't feel like a natural story. It feels staged. A comet larger than predictions, its fragments glowing as if energized, a veil that held against the full force of a solar storm. And the timing, its arrival overlapping with novas flaring and the Earth's crust cracking open, reads more like choreography than coincidence. For many astronomers and skywatchers, those alignments leave the door slightly ajar. And through that opening surge, theories once dismissed as unthinkable. One of the most whispered suggestions is that Atlas isn't simply a comet, but a carrier, its coma not just a cloud, but a dispersal system. Instead of gas venting randomly, could it be scattering microscopic payloads into the solar wind? Data, sensors, or even seeds of something more complex. On Earth, fungi and plants perfected this method, spores riding air currents to colonize new terrain. If nature solved the problem billions of years ago, might a civilization far older have scaled the same principle to the stars? And then there's the timeline. Why Oumuamua in 2017, Borisov in 2019, And now Atlas arriving during one of the most active solar cycles in decades. Surveys are improving, yes, but even NASA admits the cluster is suspicious. Some dismiss it as coincidence. Others speculate it is deliberate, a wave of objects slipping across systems, timed to coincide with windows when our detection technology is just awakening. Speculation stretches further. Some theorists describe Atlas's veil as more than debris, as a mask, a plasma shroud shaped not only by chemistry, but by design, scattering sensors and blinding telescopes at the exact moment scrutiny peaks. If that sounds too radical, consider precedent. When Oumuamua accelerated without outgassing, Harvard's Avi Loeb proposed it might have been a probe propelled by sunlight. If mainstream astrophysics can entertain that, is it truly beyond reach to wonder the same about Atlas, especially when its behavior openly breaks rules? Push that thought further. What if Atlas isn't a comet at all, but the corroded husk of something once technological? A relic drifting so long that only traces of engineered systems remain? To our instruments, it reads as ice and gas. In reality, it could be a dead construct, its protective systems leaking plasma in the guise of natural outgassing. Wild? Absolutely. But Atlas forces us into this uncomfortable territory. We can dismiss extreme ideas, soothe ourselves with traditional explanations, and maybe those answers will hold. But the contradictions persist, gnawing at every data set. There is a paradox at Atlas's core. On the surface, science gives us plausible models, alien chemistry, rare alignments, improbable clustering. But on another level, the narrative feels rehearsed, too deliberate, too exact. And until Atlas swings past perihelion and exits our skies, we may never know if we were studying a fragment of frozen rock or something far stranger. And maybe that's the most unsettling truth. If Atlas conceals its secrets inside that battered haze, then humanity may already have looked at technology, or at least evidence of engineering, without realizing it. Was Atlas simply another comet with exotic ice? Or was it a cloak, a shield, a disguised messenger drifting through? The truth is, we cannot yet know. And that ignorance may be more profound than Atlas itself. In the end, Atlas refuses to fit categories, too volatile to ignore, too strange to explain, too improbable to dismiss. It came from the silence between the stars, and it may already be slipping back out, leaving only questions in its wake. But here's the most haunting thought. If Oumuamua, Borisov, Swan, and Atlas were just the opening act, how many more are already on their way? If you're as fascinated by these mysteries as we are, hit subscribe and turn on the bell so you don't miss the next chapter in this story. Because what comes next makes Atlas's encounter look like only the beginning, and you'll want to see it.